In 1940, while the world watched the escalating air battles over Europe, the U.S. Army Air Corps issued a secret request for a super bomber. They didn't just want an upgrade to the B-17. They wanted a pressurized, long-range dreadnought of the skies, capable of flying 400 miles per hour and carrying a massive payload across the Pacific Ocean. The result was the Boeing B-29 Superfortress, a project so ambitious that it became the most expensive single undertaking of World War II. At a staggering development cost of $3 billion, $45 billion today, it actually cost $1 billion more than the Manhattan Project that created the atomic bomb. The B-29 was essentially a collection of world firsts wrapped in a sleek, polished aluminum skin. Chief designer Edward Curtis Wells realized that for a crew to survive a 15-hour mission at 30,000 feet, they could no longer rely on heavy fleece suits and oxygen masks. To solve this, Boeing engineered a fully pressurized cabin system, divided into forward and aft compartments connected by a long, pressurized tunnel over the bomb bays. This allowed the crew to work in a shirt-sleeve environment, drastically reducing fatigue and increasing combat efficiency. To move through the thin air of the stratosphere, the B-29 utilized the Boeing 117 airfoil, a high aspect ratio wing design that was so aerodynamically efficient it allowed a 60-ton bomber to handle with the grace of a much smaller aircraft. However, the B-29's most radical leap was its defensive system. Traditional bombers required gunners to manually manhandle heavy machine guns in the freezing wind. The B-29 replaced them with the General Electric Central Fire Control System. Using 5 analog computers and remote-controlled turrets, gunners sat at comfortable sighting stations and tracked enemy fighters with a joystick. The computers automatically calculated lead, gravity, and parallax, allowing the guns to fire with terrifying precision without the gunner ever touching the weapon. But this complexity pushed the limits of 1940s technology. The Wright R-3350 engines required to lift this beast were so advanced they were prone to catastrophic magnesium fires, leading to a rushed testing phase where many pilots feared the plane as much as the enemy. The B-29 was a $3 billion gamble, a high-tech, pressurized gamble that the United States hoped would end the war before the engines burned themselves out.
To truly understand the B-29, you have to look past the silver skin and into the mechanical nightmare that powered it, the Wright R-3350 duplex cyclone. This 18-cylinder, twin-row radial engine was a masterpiece of power, pushing 2,200 horsepower, but it was also a technical disaster. In the rush to get the Superfortress into the Pacific, the engines were pushed into production before they were fully tested. The result was a power plant that ran so hot it was essentially a ticking bomb. To save weight, the engine crankcases were made of magnesium alloy, which is incredibly strong but also highly flammable. If an exhaust valve failed, which happened frequently, the resulting fire would burn so hot it would ignite the magnesium, creating a white-hot blowtorch that could melt through the wing's main spar in less than 90 seconds. Pilots in the early Matterhorn missions feared their own engines more than Japanese interceptors, with many B-29s being lost to catastrophic fires before they even reached their targets. To manage this heat at high altitudes, the B-29 was equipped with 2 massive General Electric turbochargers for every engine. These were the lungs of the aircraft, compressing the thin air of the stratosphere to keep the engines breathing and the cabin pressurized. But the innovation didn't stop at the engines. The B-29's brain was the Central Fire Control System. This was essentially the world's first airborne computer network. Instead of a gunner sitting behind a window with a vibrating machine gun, the B-29 used a system of 5 remote-controlled turrets. A gunner would sit at a pedestal site, tracking an enemy fighter through a gyroscopic window. As the gunner moved the sight, analog computers, which filled a large rack in the back of the plane, calculated the wind speed, the B-29's airspeed, and the lead required to hit a moving target. The turrets would then snap into position and fire automatically. This system was so advanced that a single gunner could hand off control of multiple turrets to another crew member, creating a wall of lead that made the B-29 almost impossible to approach from the rear or the sides. The complexity of the B-29 was staggering. It contained nearly 150,000 individual parts and over 10 miles of electrical wiring. It was a massive leap from the mechanical B-17 to the electronic B-29. This was the first modern aircraft, featuring tricycle landing gear with dual wheels and a steerable nose wheel, features we take for granted today but were revolutionary for a 120,000-pound aircraft in 1944. However, all of this high-tech hardware meant the B-29 required more maintenance hours than any other aircraft in history. For every hour it spent in the air, it required dozens of hours of expert calibration on the ground. It was a $3 billion technical marvel that pushed 1940 science to its absolute breaking point, proving that in modern warfare, the side with the best computers and the most complex engines would eventually dictate the terms of surrender.
By 1944, the B-29 was ready for combat, but the high-tech dream quickly collided with a terrifying meteorological reality, the jet stream. Flying at 30,000 feet over Japan, B-29 pilots encountered 200 miles-per-hour winds they didn't know existed. Precision bombing was a failure. The winds blew the bombs miles off target. It looked like the $3 billion investment was going to be a bust. Enter General Curtis LeMay. In a move that was both brilliant and ruthless, he ordered a radical tactical shift. He stripped the B-29s of almost all their defensive guns and ammunition to save weight, allowing them to carry double the bomb load. Instead of high-altitude precision strikes, he sent them in at low altitude, 5,000 to 9,000 feet during the night. This bypassed the jet stream and forced the B-29s into the gaps of Japan's radar and searchlight defenses. This culminated in Operation Meeting House, the firebombing of Tokyo, which remains the single most destructive air raid in human history, more lethal than even the atomic strikes that followed. The B-29 transitioned from a high-altitude sniper to a low-altitude sledgehammer. The final chapter of the B-29's wartime career redefined the course of human history. On August 6, 1945, a specially modified B-29 named the Enola Gay took off from Tinian. These silver-plate B-29s had been stripped of armor and turrets to carry the 10,000-pound Little Boy atomic bomb. The B-29 was the only aircraft in the world with the payload capacity, the pressurized cabin for crew safety, and the range to deliver a nuclear weapon and return. With the subsequent bombing of Nagasaki by the B-29 Boxcar, the Superfortress achieved what no other weapon could. It forced a total surrender without a land invasion. The B-29 began the war as an experimental gamble that cost more than the bomb itself, but it ended the war as the ultimate symbol of American industrial and scientific supremacy.